Good evening, everybody. Welcome to our Mathagon webinar called 6 Teachers Share How They Use Polypad. We are really excited that you're here with us tonight. We have some wonderful teachers who are going to share how they've used Polypad on Mathagon with their students over this past school year. My name is David Porras. I am a 6th and 7th grade math teacher in Weston, Massachusetts, which is outside of Boston in the United States. And I'm also the head of content for Mathagon. And I'm really excited to host this webinar this evening. Before I turn it over to the 6 teachers who are sharing, just a quick tour of Mathagon. Here I am at mathagon.org. As you may know, Mathagon is interactive and personalized and free. And we have courses. Polypad will be spending a lot of time at tonight. And we have a whole host of activities as well. So I encourage you to spend some time on mathagon.org if this is your first time experiencing Mathagon. We're just going to be looking at Polypad tonight, but there's all sorts of wonderful things in courses and activities as well. I'm going to go to Polypad here, and you'll see when you go to Polypad under tiles, we have all sorts of tiles. We have geometry tiles and number tiles, fractions, algebra, probability, and tools and utensils. These tiles get put on the canvas, so I could take a fraction bar and put it on the canvas. You can see here those look like decimal bars, not fraction bars, and under settings I have it set to decimal, but you can change it to fraction or percentage as well. You could turn off the number labels, all sorts of options here. A new feature that we just added is the ability to keep certain sections shaded in and certain not. With the triangular tab, the black tab changes the size, and the triangular tab changes what's shaded in and what's not. That's a new feature that just came out this past week. What also is new on Polypad is this What's New option here. So if you click on What's New, anytime you come to Polypad, you can see if any new things have been added. So you can go read this and play and explore with what's new. The purpose of the webinar again tonight is to hear from teachers how they've been using Polypad. If you want to learn more about how to use Polypad, you can go to Library and click on the tutorial button. If you do, it'll bring you to this page, which has a number of tutorials about how to use Polypad. So if you wanted a general introduction, you could click on this, and there's a tutorial page for each of the tile types. So if you want to learn about using the number tiles in Polypad, you could click on that one. And for each of the tiles, there's a short video of how to use each type. So here's a video on number tiles, and then a canvas where you could try it out on your own. Here's a video on the number bars, and then you could try it out on your own. So that's all here under tutorials. The other thing in Polypad is if you click on activities, it'll bring you to the task page. And you can see here there is a number of activities to do, including all those tutorials. There are student explorations, lesson plans, puzzles and games, teaching ideas, and the tutorials that I just showed you. And if you're exploring a topic, say the Pythagorean theorem, you could search for that topic, and there's a task on the Pythagorean theorem. And finally, I want to share with you the link that we're going to be using for the webinar tonight. If you go to mathagon.org/PD/May26. So mathagon.org/PD/MAY26. I'll put that in the chat. It'll bring you to this page. Again, mathagon.org/PD/MAY26. And what you see here are links to all the presenters that we're going to hear from tonight. If you click on their name, it'll take you to their page on Twitter. Give them a follow as a sign of your appreciation, and to learn all sorts of wonderful ideas beyond what you're going to hear tonight. Here are the links that I just showed you, the task page, the tutorial page. I also want to show you, there's another page. If I click on this link, it'll go here. This is our tutorial videos and webinar. So we have videos on multiplication by heart, flashcards, making classes, sharing polypads, and so on. And then here are videos of the webinars that we've done in the past. So you could go watch some previous webinars. These first two give a like Polypad 101 overview of all the tiles. First one focused at the elementary level, second one at the middle school level. And then here's one that was sort of a deep dive into numbers and fractions. So that you can find at this link. I also encourage you to check out our summer webinar series. If you go to mathagon.org/PD, it'll redirect you to this site with our summer webinar schedule. You can see we're doing the Mathagon 101 again for the elementary and the secondary level. We have one just focused on teacher tools, some deep dives into numbers, geometry, and probability. And then at the end of August, some back to school with Mathagon webinars, again, focused at the elementary and the secondary level. And finally, if you're interested in some Mathagon training at your school or district level, a more immersive experience for teachers in your district, there is all sorts of information about the range of professional development that we could offer at a school and district level. So go to this document, check it out. There's an email address there to get in touch with us if you want more information or if you want to schedule something. Again, all those links are available here, which is mathagon.org/PD/May26. So that is my quick overview. Thank you for joining us tonight. If you have questions throughout the event, please feel free to put them in the chat. Each of these 5 amazing teachers will have about 10 to 12 minutes to give you an overview of some of the ways they've been using Polypad in their classes. If you have questions as they're presenting, feel free to put them in the chat. I'll be watching the chat. We might not get to all of them during their 10 to 12 minute chunk of time, and we'll happily answer any other questions at the end. So without further ado, thank you again for joining us, and I will now turn it over to Mark. Mark, take it away.
Thanks, David. Hi, everybody. My name is Mark Kircher, and I am a math teacher in upstate New York, just outside of Albany, and I am a 27-year veteran of the math classroom. And for all of my career, as long as I've been doing this game, I've embraced instructional technology when it comes to mathematics. And when the Mathagon Polypad came around, I realized very quickly that it is a game changer. And I am just so thrilled to have this opportunity to share a little bit with you, share a little bit of my passion for the Polypad. And I'm going to sort of focus on the custom polygon tool. So here we go. The equilateral triangle is like a great classic example of a reptile because you can make equilateral triangles out of equilateral triangles. Well, then I also discovered this, it's called a self-tiling tile set. Try saying that multiple times fast. I don't think you can do it. But this is just a great way to get students to explore what it is that goes into making these shapes. And then how can we use something called the custom polygon tool to make it. So if you want to have a Polypad open along and play along with me, great. If you just want to watch, that's fine too. So these 4 shapes are called the self-tiling tile set, meaning I can take all 4 of those shapes and put them together to make a scaled up version of this shape, or a scaled up version of this shape, or this one, or this one. So I would say to the kids, okay, let's start first with this yellow L. What do you see that being composed of? And I think it's going to be pretty clear to all of us that that's made up of 3 squares. So you can just grab 3 little square tiles here and put them together. And I always like to tell the kids that these are so great, these little polygons, because it's almost like they're magnetized. They snap together nicely. All right. So we can take those 3 tiles, and that is a pretty good version of that. But now what if I wanted to make a single tile that is the same as the 3 squares made up? So then you're going to grab this custom polygon tool, and it has like this green funky shape. I don't like to give the kids a lot of structure. I think about it in terms of like, I'm not a big worksheet packet guy. I like to give them just sort of a bare bones and a blank canvas a lot of times and just say, go ahead and play. And this is a mathematical playground. You've seen that tag on there, and I fully embrace that. So we've got this L-shaped block. I'm going to grab this custom polygon tool. So let me show you how this works. So this custom polygon tool starts out as like this sort of weird looking pentagon, right? So you can grab these vertices and it'll snap to the vertices of the stock polygons that you dropped into the canvas. So I can just drag these vertices right to the vertices of these blue squares. And now you're like, well, now what do you do, smarty pants? You don't have enough vertices. All you do is you click on the segment and it adds another vertex. Or if you need to get rid of a vertex, you click on that and it gets rid of it. All right. So I've got my little custom polygon, this L-shaped block here. Now what can you do with it? Well, if you take that custom polygon, and you can see I've highlighted it, down here on the bottom, you've got a tool that says fix vertices. And what that's going to do is it's going to sort of lock that polygon, not in place, that's a different thing. Fix vertices is going to prevent me from accidentally sort of mutating this polygon, all right? But now I have the ability to rotate it, right? I can also flip it. There's a flip button down here. So that custom polygon tool, it was funny, last week when we got together and we were doing some pre-gaming for tonight's session, David asked us, okay, what's your favorite thing on the Polypad? And most of us all agreed that the custom polygon tool is just really, really cool. You can do some pretty cool stuff with it. All right, so there's that one there. Now, let's make another one real quick. You can see I've got an extra little decagon here. So I'm going to start to work on this sort of salmon colored shape here. All right. So I would ask the kids, okay, what do you see here? How do you decompose this shape right here? So I would start off with maybe a square or two, right? So you got a couple squares. And then I can sort of imagine that there's a little right triangle, a little isosceles right triangle on the edge here. And you can use the drawing tools to sort of mark up your diagram and now sort of almost blueprint how you're going to build this polygon. So I'm going to go ahead and grab another little right triangle, put it on the end there. And if you want to copy something in the Polypad, all you do is hit the C button and you get a clone. You get a duplication of that polygon, which is pretty nice. All right. So that I think is a pretty good version of that. So again, I'm going to grab this custom polygon tool right here. And I'm just going to drag these vertices to the vertices of the different polygons within my shape here. And this one happens to be a pentagon, so I don't need to add or delete vertices. And then fix the vertices. All right. So really, really slick. I mean, that custom polygon tool, think about it, if you teach geometry, that custom polygon tool, you can do so much with it. It's really, really fantastic. Then what if you say you gave the kids this shape, right? I'm going to sort of pretend, oh, let's pretend I gave you this shape. How would you dissect this shape? Right? We always talk about how kids use dissections in biology. How would you dissect this shape? How do you see this shape being sort of chopped up, if you will? In dissection puzzles, that's a whole nother black hole that you can fall down. So you can take the cut tool now. So if I highlight a shape and hit this button down here, it says cut. Now you can say, well, maybe I see it being cut like this into a parallelogram and an isosceles right triangle. Or maybe I see that shape being cut into two isosceles right triangles of different sizes, right? And then you could even subdivide this triangle down into a smaller number of isosceles right triangles. And then you could even take that shape and divide that into a smaller number of isosceles right triangles, and so on and so forth. You get the idea. So really, for me, as a geometry teacher, the custom polygon tool, being able to cut and just dissect all those shapes, it's just a great thing for me to do. So I invite you to do a deep dive of your own into these reptiles here. And then the last thing I'll just mention real quick is that I have recently acquired a Cricut. So I'm able to create these shapes in the Polypad and then send the shapes to the Cricut software. And then if you're not familiar with what a Cricut is, it's kind of like a low-end laser cutter. I can't afford a laser cutter because they're thousands of dollars, but I can afford a Cricut. So thank you to my wife by letting me purchase that as an early Father's Day present, by the way. And I just made these shapes out of that sort of cheapo craft foam, right? And you send it to the Cricut, you cut them out, and then you've got some nice little hands-on, like let's get the kids back into hands-on puzzle solving and playing with geometry. Just put these in a little Ziploc bag or a little envelope, get a whole bunch of them for your classroom. And now your kids are going from digital to analog and back and forth. And it's just a really great exploration tool. So I thank you for joining us tonight. And I'm going to turn it back to David, who's going to bring us on to our next speaker. So thanks, everybody.
Thanks, Mark. There was a lot of wows and awesome in the chat. Can you give a 30-second overview? Because You got 1 minute left. People are asking how you got the math shapes to the cricket. Is that
good question.
Quickly?
Good question. So to get the shapes from the Mastagon to the cricket, so I would go down here. Let's say that this is my, let me undo just a little bit.
Yeah.
Okay. So I would take this shape right here and I would basically just take a picture of it, because the Cricut software accepts JPEGs and PNGs. So you just send it to the Cricut software as a JPEG or PNG, and then you connect your Cricut Maker to it or whatever Cricut you got, and boom. And if you need more information about that, hit me up on Twitter. Awesome. Or stalk me on whatever, whatever platform you can find me on. So thank you.
That is great. And like, what a great example of taking what's done in a virtual world and then making a physical set of that for kids to play with. I think there's always going to be a need, no matter how amazing Mathagon gets with the virtual manipulatives, some things there's value for doing it hands-on as well, right? And so to be able to take something that students made, and you don't need the fancy $1,000 device, but you can do it on a Cricut for much cheaper, is a great example of that. Thank you. We're going to see some more uses of the cut tool down the road. I have found it just comes up all the time. Area of shapes. I did something where we were just exploring Pythagorean theorem, and you built the squares on the legs, and we wanted to fit that into the square on the hypotenuse, and being able to cut it up and just fill the pieces in was a really powerful exploration for students. So thanks for sharing, Mark. I'm putting the link again in the chat where all these links are, and you can find at the top a link to Mark's Twitter account. Give him a follow. The 5 teachers and I were chatting at the beginning about how the professional development that we've got as teachers on Twitter is unbelievable. It is not as good as what you're getting tonight at this webinar, mind you, but it's pretty good. So if you are not a math teacher on Twitter, I encourage you to go check that out. All right. Next up is Jenna. So I will turn it over to Jenna, who's next on our program. Thanks, Jenna.
Awesome. Thanks, David. Hi, everybody. I'm Jenna Myers. I am a grade 7 math teacher from Ontario, Canada. I wanted to walk you guys through a quick day in the life of one of our grade 7 lessons. So my class has been remote this entire school year. And I set out at the beginning of the year saying, you know what, I want to make this as close to the face-to-face experience that I know my students are used to, that they're comfortable with, and give them that opportunity to still explore and play and make sense of the math. And in comes Mathagon Polypad, and it truly was the answer to solving that goal, or finding a means to achieve that goal. So I thought I'd walk you through a typical 4-part math lesson and just how I use Polypad for all 4 parts of every lesson that we do. And I wanted to start with our minds on. So let me just share here. And this is a typical lesson that I would do with my grade 7s, where they would know exactly what we're working away at. We'd have our lesson learning goal. And here, just for the sake of tonight, I'm looking at how to make sense of the formula for calculating the area of a trapezoid. But again, we use Polypad for everything that we've done all year long, and my students are very comfortable with it and they love it. So for this lesson in particular, I let students take a look at this picture where they could see a trapezoid, and I asked them to create a trapezoid using 3 pattern blocks. Once they were finished with that, I asked that they find the area of that trapezoid if the unit of measure was 1 green triangle, and then again, if the unit of measure was 1 blue parallelogram. So from there, I was able to give students a link to something very simple. So here we have nothing fancy, but I love how Mark mentioned that giving them room to play and letting this be our mathematical playground is pretty powerful. So I grabbed some of the polygons under the geometry tab over here. I did use the settings tool on the right-hand side. So when I click on the hammer over here, you can see that I've chosen to use alternate tile colors. And the reason for that is just my students are used to seeing the yellow hexagon, the blue parallelogram, the red trapezoid, and the green triangle. So because I wanted to make this as close to a face-to-face experience for my remote students, I chose those alternate colors. So students were given this blank, or not blank, but fairly blank Polypad here to move around and try to create their trapezoid. And my students are pretty comfortable with picking up that polygon, and they can make copies of it if they needed to, and they can make however they can make their trapezoid. The nice thing about Polypad is that my students had that flexibility and that freedom, but we also had some time to share our work. So students are comfortable grabbing a quick screen grab or a quick screenshot. And this is something that the grade 7s put together. So I shared, again, this link, and students had access to these slides where they put in their trapezoid that they had created. And then if the unit of measure was 1 green triangle, what is the area? And very quickly, I could see which students were paying attention to the instructions of using 3 pattern blocks, and which students understand that idea of area. So it was a really quick way for me to get an understanding or get an overview of who's ready for this, who's ready to really explore and find the formula for area of a trapezoid. From our Minds-On activity, we usually jump into an action task. So first, I showed this in my slides to the students, and we did a quick estimate. So we're using the grid, and we saw that there are a few measurements here. And then I said, okay, let's try it out. Let's dive in and let's use Mathagon Polypad. And really, we're going to make sure that it's not just an estimate. We're going to find the exact area of that airplane wing. So I always give my students the reminder to make sure that they open up the link, that they sign in to Mathagon Polypad. I constantly remind my students to make sure that they're saving a copy. I just want to make sure that nobody ever loses their work. And then just make sure that they're saving as they go. So the action task looked very similar. So here it is on my Polypad. You can see that I do have a grid in the background, and that was more or less so students could really see that shape and connect it with other shapes that they already know. So exact same measurements, and I use that favorite customizable polygon, just like what Mark was talking about too, to make that trapezoid. So again, Mark kind of showed us how we can move things around, how we can lock it into place, how we can click on one of the vertices to get rid of it, so on and so forth. And so I used that. And again, I assigned this Polypad, and this is what students got to work away at. The nice thing about seeing this Polypad, or my favorite thing probably, is that I have it saved in my library here. And this is my template for students. They know what the task is. I've outlined each part of it, but I can see as a teacher everything that my students are doing in real time. So as my students press save, so their copy over here, rather than says assign, it says save copy or save. As they press save, I can see what they're working on. So in real time, they're able to make their math visible, and I'm able to check in and make sure that they're able to make sense of this math. So the other thing is that this then leads into our consolidation part of our 4-part math lesson. So scrolling through, I'm looking to see who used what strategy. So I can see at a glance that there's a student who decided to say, you know what, I'm very comfortable with finding the area of a rectangle. So I'm going to pretend like I've got a rectangle here, and then I'll just subtract the little triangle at the top and triangle at the bottom. I can also see that there are some students who cut that trapezoid here into 2 triangles and a rectangle. And then I can also see, we'll discard that, that's fine. I can also see that I've got a student here who decided to duplicate that original trapezoid, flip that trapezoid. So remember, we have that option at the bottom to flip the shape. So she flipped it, and then I can see some of her thinking. So again, this Mathagon Polypad is making my students' thinking visible, and something that in remote I was missing before I found Polypad. Typically, I could walk around the classroom, peek over a student's shoulder, and know that they're making sense of the math and that they really truly understand. But here I can see, again, that it's just like being in face-to-face. I can see when this student did 1.5 plus 1.1 equals 2.6 meters. I can see that she was adding this one side of our trapezoid over here. I can see that she then added on that 0.9. So she's making sense of the fact that she's looking at one side and then its parallel side. So I did use this one for consolidation of this task, and I had the students pick apart these numbers. I said, okay, here's student number 3's work, and what do you think she meant when she did 1.5 plus 1.1? And we picked it apart, and the students were able to say, you know what, if we take both bases of that trapezoid and add them together, then all we have to do is cut and then multiply it by the height, sorry. Then all we have to do is cut it in half, and we've got that area. And I already know how to do area of a parallelogram. So the students, without so much guidance from myself, but instead because they had the opportunity to explore and to play and to manipulate, these shapes, they made sense of the formula for area of a trapezoid kind of on their own, which was amazing. So we consolidated that. I did end up showing them a quick video from Math is Visual on how to make sense of the formula for area of a trapezoid. And then from there, I was able to assign a independent kind of worksheet of sorts. But again, just a time for them to practice what we had already, what we had learned. So here I asked students to use that formula that we discovered in class, and they could find the area of each trapezoid and then reflect on how the area of a parallelogram is helpful in finding the area of a trapezoid. So again, we were able to use Mathigon Polypad for our minds-on, our action task. I used students' work in real time to consolidate their thinking, and then they were assigned independent work to kind of prove and practice that they understand what was taught in that lesson. So that's a typical day in the life of my grade 7 class, and that's, I guess, that's what I'd like to share today.
Thank you so much, Jenna. That was an amazing lesson start to finish, not just the Polypad aspect of it, but just the way you approach the lesson and scaffold the activities. I might be asking you for that Google slide because we are looking at trapezoids next week in my 6th grade class. So thank you so much. Can you talk a little bit about if you're teaching that lesson in person down the road, what parts of it, I know I'm putting you on the spot here, but what parts of it you might continue to use? You had talked about there's certainly great value in what you shared where kids were at home, but any parts of that you could see keeping as part of your practice?
Honestly, I think I'll still use Mathigon Polypad as much as I possibly can, even when I am back to face-to-face. I might have maybe changed and maybe taken the minds on and had them actually manipulate those pattern blocks to create their original trapezoid. But I love that I could take the kind of textbook problem and I could just assign measurements and lengths to parts of that trapezoid, and I could take it directly from a text that all of our grade 7 teachers are using, and I could make it so that they could actually see it in real life. So it'd be a little bit trickier to do that with the actual pattern blocks, but I can see us using Mathigon Polypad for everything going forward, even face-to-face, truly.
Awesome, thanks. I'm in person, but we're exploring area of parallelograms in a couple of days, and I'm just giving them a canvas with like 12 parallelograms and just say, go find the area, and just to be able to cut and move the triangle over. You know, in the past, I've done it with graph paper, and they cut it out and they tape it together, and it gets messy. And yes, you're actually touching the paper, but I think there is value to be gained in doing lots of examples in a virtual environment where it's so easy to do. So thank you so much, Jenna. It's awesome. A lot of great comments in the chat. So go give a scroll about how awesome that was if you haven't read the chat yet. I'm putting in the chat a link to our site that has all the links, but also in there's a link to the Mathigon tutorial and webinar page. And there are some videos there that talk about how to import students to make a class, and then how to assign canvases to classes. So there's a lot of questions in the chat about that process. So in that link on the tutorials and webinars, that's all explained. Shannon saying, which one do you recommend? They're both like 5-minute videos. So I would start with the one where it tells you how to make classes. So once you have a class made, then you can very easily share the canvas with that class. Awesome. All right, Melissa is up next. So I'll turn it over to Melissa. Melissa, you want to give a quick introduction and then take it away? All right.
Great, thanks. So yes, welcome everybody. My name is Melissa Dean, and I am currently a grade 7 homeroom teacher in the bustling small town metropolis of Steinbach, Manitoba, which is just about half an hour south of Winnipeg. And I have been teaching for close to 20 years, and as has been said already, somehow I fell down the rabbit hole of discovering the Polypad in the Mathigon world, and yes, someone is bold in Steinbach. I just have to give a shout out to that. Yeah, so I fell down sort of somehow the rabbit hole of the Mathigon world, again, probably through Twitter. And I will give a shout out again. If you are not on Twitter, please be on the Twitter. So I wanted to share with you all tonight how I'm using the Polypad to help build multiplication relationships for my grade 7 students. One of the things I'm super, super passionate about is the age-old, ongoing, lifelong debate versus memorizing your times tables and building a conceptual understanding of what mathematics really is and how we understand numbers. So my first mind-blowing moment as a mathematician came not that long ago when I was first introduced to the prime climb pictures. And we can see that the prime climb, I was super excited when the prime factor circles joined the scene on the Polypad. So if you're not familiar with the prime climb and prime factor circles, they are a super amazing tool to help your students see the relationship between prime factors and building multiplication. Yes, Davis just dropped the prime climb game. It's brilliant. And it was been one of my introductory activities for the last several years. So if I want to, you can see they have up to 25 here. If I just drag and drop some of the numbers on here, they come on as circles. You can, as we've seen, copy them just like all the other tiles. But the thing that I love about it the most on the Polygon or the Polypad is that I can pull the factors apart and see them separately in their own, and it relabels it. And then I can manipulate the circles to find different factors that have an equivalent representation. So this understanding of multiplication has been one that I have been working on with my grade 7 students since September. And what you can see on the screen is the warm-up activity that we did in class today. So initially I started out with the problem of 35 times 6. And then I asked my students to break down what factors they saw according to the colors. I do have a couple colorblind students, so have to kind of navigate that a little bit. I always check to make sure you can, put in whatever numbers you want down here and it will drag and drop them on here. But so I asked them to identify what the factors were, and we broke that down. And then I said, I want you to find all the rearrangements that you can to see what are some equivalent statements, equivalent expressions to this initial one. So you can see a record. So today what I chose to do was, as the warm up, they actually worked on, my students are actually face to face, although some of them are downstairs in a different room in the same building. So I'm currently teaching kind of a hybrid model where I have 3/4 of my classroom in the classroom with me, and then I have some of my classroom downstairs following along while I'm screen sharing on Zoom. So that is why for this task, I had them work on a piece of paper or a piece of whiteboard, and then we consolidated through having a conversation. So you can see the list here, all the ones that they came up with. And then as we're going through this, one of my students said to me, Mrs. Dean, why would we ever do this? Isn't like, yay for knowing prime factors, but who sits down and thinks about all the prime factors in their head while they're listening to try to do this question? Isn't it more efficient to do a different way? And I said, thank you for asking that question. And I wrote it down while they were talking because they're following along. And I said, that's a fantastic question. Let's talk about that. Because I know one of the things I struggle with my students so much is that they just blindly put numbers into algorithms without actually having a sense of why on earth they're doing it. And they don't always see the pattern. So I said, fantastic, I'm going to come back to that question. And I walked them through here and I said, you know what? One of the things that stands out to me, if I was going to try to do this with mental math, is I like the 70 times 3. And so I walked them through my thinking, but then I pulled them out and was able to create this in different circles were my original question and the rearrangement. And then I said, what do you notice? What do you wonder? My two favorite questions to ask in a math classroom, really any classroom. I teach science and social studies and ELA, and I ask them that all the time. But I said, so what do you notice? What do you wonder? And they immediately came up with, it's all the same colors. One side is multiplied by 2, the other side is divided by 2. Great, now we're into halving and doubling. And so it really truly is a place where my students are playing around with the numbers and learning to see connections. So if that is something that you are super passionate about and building for your students, this is one way you can really do it. You can, I will say, Jenna showed using sort of the classroom tool. I have all my saved Polypads, but you can see I have a record of, I do the same thing. You can see I have actually, because I never know at any moment in time whether I'm going to be moved all the way to remote or not. I have a bunch of Polypads planned ahead and they're saved and they're just easily linked. My favorite thing that I discovered, well, there's lots of, let's be honest, they're all my favorite things. But for those of you who use Google Classroom, if I wanted to send any of these Polypads to my Google Class cancel. If I wanted to send any of these Polypads to my class for my students to find, my students are super awesome at not being able to find things. So sometimes, especially when you teach 12-year-olds in May, you got to make it as straightforward as possible. So if you want to, you can click on this button and you can see it will just embed it in wherever you want. So if I click on the Google Classroom little link there, it makes it into an assignment right away for me. And then it puts it both in the classwork tab and the stream. And then there's no way my students, I can't find the Polypad on Mathagon. And I say, just open your Google Classroom, friends. So lots of places to play. This is just one place that I'm playing around with my students, but helping them build that conceptual understanding of numbers. Along with the multiplying, right? We also have all of the other number cards, the number tools, using the multiplication grid. And if you have never, ever, 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 I'm going to give a plug for, yes, 100% free. I just see that as a question there. For both you as the teacher and students. But if you've never, ever explored exploding dots, this is new on the Polypad. Oh my goodness. Go explode some dots and experience the joy of hearing James Tanton say kapow if you do the actual Exploding Dots website. If you share a link to the, yes, you can set it so that it will just send it right away to the kids. When they click on the link, it just opens the Polypad in their Google account. So I had a kid yesterday forget to do it that way, and then he hadn't saved it. He couldn't log in. When I put it on the Google Classroom, the kids are already logged in. It already logs into Mathagon for them. So that's just one way that I'm using it. I hope you found some value in that, and you can see the passion coming through, because it's a really great way to have your kids play around with numbers. So I will stop share and turn it back over to David.
Thank you so much, Melissa. It's, first of all, I must say, it's good to know that 7th grade students across the globe are consistently really bad at finding things, because my kids also can't find links that are shared in the same place every single time. So yes, being able to assign in Google Classroom is a really nice feature. And then it takes that Polypad and it shares that. And then when students start working on it and they click save copy, it changes the link, and then it saves a copy in their account. So that's how they get that copy and make it from there. I also put in the link in the chat, a link to a Polypad task on using the number tiles to show the concept of halving and doubling. So I have a big grid of number tiles, and you cut it in half and you move it down, and you see that, you know, the number of tiles on this side doubled and the other side halved, but I never thought to do that in the prime factor circles. You just move the two. And what a great visual to show that I'm doubling one and halving the other by just switching where the two goes. What a powerful idea. So thank you for sharing that. The other thing I just want to mention, Melissa had a lot of Polypads, as do I. Another feature on our list that will be coming at some point is folders, so people can organize all the Polypads that they have. And I also want Melissa to be able to share all those amazing number talks that she's made. So another feature that will be coming down the road is the ability to mark some Polypads in like a public folder. And then so as a teacher, you could take that link and it'll have all your public Polypads that you've made. So if Melissa would be so nice to share them with me, she could just kind of check the Polypads she wants to put in her public folder and then put the link out, and then there we are. And so that's something that we're really excited about as a way for teachers to share all the wonderful things that they've done out there. So yes, I think that would be amazing. Very self-serving for me. It would be amazing because I get all these great, so it would be great. And so we think that's coming as well. Thanks, Melissa. Awesome. Next up is Chad. So I will mute myself and turn it over to Chad.
Hello, I'm Chad Banky. I'm finishing my 9th year teaching out of Wisconsin. I don't think I saw any Wisconsinites in the chat, just outside of Milwaukee. So I guess first I'll start off by just talking about ease of use. Like I will show you some polypads that I've made recently, but just ease of use to start. I think I started by really just looking for a place that I could find. I always talked with solving equations about a balance scale, and I was always looking for a good balance scale, and probably somewhere on Twitter I just stumbled upon Mathagon. But I want a couple of people started talking about kids playing, and really one of the things that I've done a lot this year is just allowing kids to just play, and these are just some of the artworks that kids have made in Mathagon. So just using all the different polygons, and I have them. If I see a kid working on one, I'll ask him to share it with me. This is the most recent one. So yeah. Sorry, I'm new to Zoom here, so there we go. And how you do that, how you download an image, like let's say you've got whatever it is in there. There's just an easy function over here where you can just download it as a PNG. So, and then copy and paste that into a whatever you want. So like I was saying, I kind of really just stumbled upon it where it's just pretty simple. You can put in whatever you want. I'll use that symbol there. And I was looking for, I always had the concept of using a balance scale, but I could never find a good one. The nice thing, just like a lot of these features, you can type in whatever numbers you want. So kind of just started with that. Obviously, you want it to be balanced. You have to click on the scale and click balance, and then we get into putting in, doing inverse operations. So I have to put in a negative there, but now it's not balanced anymore. So I have to put in a negative over here. And what's nice is it shows that I need to change my settings. It shows that making a 0 pair there, and then shows what it would make over here. So that's kind of where it started with, is just really looking for a balance scale. And like I'm showing you now, this is not something that I have to have made in advance. There's plenty of ones that are made in advance with solving equations, but this is just something I would just pull it up while I'm solving equations. Currently in 6th grade, I'm talking about integers. So I would just talking about numbers and what happens as you go further in each direction on a number line. So, I would just pull up a number line and then make it grow. And then we would just talk about where the points would be, and, talking about absolute value and all that stuff. So this is, again, just something you could do just randomly. I actually just made one today, and this took me probably 5 minutes. It's not anything spectacular, but I think I had the idea from seeing somebody else's on Twitter, where I said cut, flip, and rotate the trapezoid to find the area, and giving them the opportunity to do whatever they want to find the area of that trapezoid before knowing the area formula.
Hey,
and
Chad, I'm gonna interrupt you for 1 sec. I apologize, but what I want to share with folks is there was a question in the chat. There's the question builder tool. So Chad put
yes,
in,
I was
awesome. Yeah, great. Go ahead. I will.
So stop. On my end, if you go down to tools and utensils here, question builder, I drag that into there, and I put the correct answer of 18. And I put this text in there using the text box feature. But then I'll copy this and put it into an incognito window that I learned from David. But this is what it would look like on the student's end, where theirs would be blank, and then they would, once they determine what the answer is, let's say they put 20, it's wrong. And once they typed in the correct answer, it would tell them that it's correct. So that's what it would look like on the student and because if you change yours, notice mine says teacher dashboard, they would have a student dashboard, and theirs would not be with the answer there. So that's what that looks like. Yes, can you zoom in on the number line? You can change the divisions. You can change the step sizes. You can change all these things. So here's one I think I got this idea from seeing something that David had put on Twitter, where I was trying to, I'm kind of preparing for next year, trying to find different things that I can do using Mathagon's Polypad. So I just made this. I used the multiplication grid, and you can kind of make this, you can drag it to be what you want. And you could do different bases and all sorts of things. And then I just put in the answers of how big each size was. So that's another one that I shared. Again, this is not something that takes an incredible amount of time. This is one thing that we're going to be getting into in the next week in 6th grade is plotting points in the coordinate plane. They've only done it in the first quadrant. So I just, again, something really quickly, I just used the construction tool. I did line, and then I plotted a point. And then I decided to put in a question builder for each one of the numbers in the coordinate, in the ordered pair. And then that would tell them if it's right. So, but again, something really quick. Another one on area of a triangle. And again, if they want to, they can use the ruler to make it bigger and smaller. And then I think there's another one by Math for Love. This is from UCube's How Close to 100, where my kids have really loved using the dice. Actually, that's how I found out about how the balance wasn't working, by kids just playing around. So this is one where this would be working on their factors. So it's 3 times 2, and then they'd have to make this 1 6. So, and they could do 2 by 3, they could be 3 by 2, and then they put it in, and then they try to see how close they could get to 100. This is one that David had shared actually on Twitter. Just my kids playing around, some kids playing around, and they saw, well, this shouldn't be balanced. 3 should outweigh the 2. And I noticed David had made one where this is probably one of my students' favorites that I know is on the Mathagon library, where you have to randomize it and try to fit them onto the balance scales. Just quickly to wrap it up here, some of my students' favorite, again, this is just letting kids play around. And like I said, this year I'm doing rotations in my classroom, and students have choices. One of my students' favorite, so whoever plugged for anybody at Mathagon who came up with this one, kids love the Genius Square, where you have to spin the spinners. And however that works, I can't on the spot here. So you have to spin all these and then bring in all the squares. But it just goes back to, like I started at the beginning, just letting kids play around. I know there's plenty of things that I haven't come across yet this year, and I look forward to just learning more about Mathagon and just playing around. So
awesome. Thank you, Chad. So many amazing ideas that you shared there. I just want to give a plug too for, it was Chad that had got in touch with us to say the dice aren't working on the balance scale. And so, that was a quick thing to fix. And I have done so many just fun warm-ups with kids with dice on the balance scale. I had a playing card face up and then a playing card face down. And I put a couple of dice on the balance scale, and it was unbalanced. And then we rolled the dice, and I said, can you predict the card after 4 rolls? And, as the dice changed, the scale changed. And so kids with each roll of the dice were able to get more information about what that card could be. And so awesome. Yeah, so many great things there. In the link, mathagon.org/pd/May26 are all the links that Chad had talked about. There are some that are in the task page and some that are not. Can 2 students use the same Polypad? Not yet. There's been a lot of teachers have shared how valuable it will be for students to play a game like that at the same time. So we have heard that teacher feedback and are hopeful to get that out at some point down the road. But again, as you have ideas, please share that idea of dice on the balance scale that students of Chad saw has created so many wonderful explorations. Awesome. Thanks, Chad. And closing out tonight is Ada. We might go a few minutes past 8. I'm going to give Ada her full 10 minutes. Of course, you can get up and leave anytime you want, right? So Ada's going to go 10 minutes, and then we'll stay on and answer any questions that people have. So close us out, Ada.
Yeah, okay. Hi, I'm Meda Aydemir. I'm originally from Turkey. I live in California right now. I'm a middle school math teacher. I have a website called Fun Math Fun. And I also work like part-time as a member of Matigon's content team. So before I show you, just let me very quickly share my screen with you. Just, okay, you can see right. Okay, I wanted to show you these comments that I showed in a webinar like a few weeks ago in Turkey. These are the things that I've done with Polypad that I most of the time shared over Twitter. I publish them on the tasks page of Metagon or on my website. And you can see the sky is the limit here. You can create anything you want and everything you want. Like puzzles and games are my favorite. I'm going to show you on my website here how many games and puzzles I've created. One of my favorite is the Battleship game using Star Wars ships and everything you see in here. And I think that Polypad is really kind of encourages the creativity both in students and teachers with all those manipulatives in here. And also as a teacher, I mostly teach the kids, ESL kids, I mean English as secondary language. So giving them opportunity to express their thinking visually rather than like words, that is like very valuable, extremely valuable for those students as well. And one more thing in here before I move to the Galton board example, I also use the protractor tool and the ruler tool a lot in here, because unlike the other geometrical tools and interactive platforms, here students still need to use the protractor to measure the angle or measure the side of the polygon or square or anything like that. So this is very important, especially in elementary school and middle school, because this is a skill we all want them to have, especially in this remote learning time. They still need to use the protractor to measure the angle instead of just clicking and getting the answer. So this is very important as well. And one last thing before I move on, here in a few weeks of time, I'll be having a course about fractals. And very quickly, I'm showing you my polypads, the assigned polypads. I could draw like different versions of Sierpinski triangle. I could draw the co-snowflake and the mango sponge and the carpet version. Also, I can mention the reptiles as fractal geometry, as a part of fractal geometry, or speedruns, and all sorts of things. And in some of those polypads, students are asked to draw the next shape in line. For example, this one. Let me show you this. Let me change the dark mode really quick. Here, they need to draw the next shape, for example. And in that one also, this is the tile already exists under the geometry tools in here. As you see, the blue one is the biggest one, but I've created the green one, a bigger version. And my question is, how can you create a bigger version, or smaller is a little bit impossible, but a bigger version of this tile? What are the shortcuts you use and how you can do that? So that's another question. Also, let me show you this one really quick. In that one, there's kind of the shape is given to them, and this time they're asked to calculate the parameters, areas. As Chad already mentioned, I use question builder, and I already wrote the answers. They're supposed to write the answers and work on that as well. And they've got like plenty of space to work on. They can copy and paste and make it bigger, the next iteration and everything. So let me just stop in here because we've got limited time. And today, in fact, I really want to talk about the Galton board. I have got a version in here, if you can see. There are like 3,000 marbles in here. There are pegs and slots. When I make it like upside down, all the marbles fall through those pegs and randomly located in those slots. Now, I want to kind of make a simulation of this by using Polypad. And I created that one. In fact, what I have done here is just putting a bunch of hexagons in here and making a triangular pattern. I also included coins to create the randomness because it's right or left. So the kids need to just select them all, flip them all. And for each turn in here, they're gonna decide like this one is right, right, left, left. I made a little video here. So when I'm talking, you can see. And here they will actually work on the experimental probability. And you can also use the pen tools to trace it if you cannot see like me, but the kids can see, so they're not using tracing. And they can draw their own graphs. And after that, like I have collected the data from them, and we talked about the graphs, how similar they are to each other. And then we were ready to move on to the theoretical probability part, what is actually happening. And that time I asked them to list the possible paths, all of them. And there were like 4 turns in here. It means 4 decisions. So they need to calculate the sample space. For each of them, there are 2 options, 2 to the power of 4. We have got like 16 routes in here. And then also they have calculated the probability of which route ends up where. And then they come up with like the numbers 1, 4, 6, 4, 1. Let me just very quickly right here. They also list their findings to the table. Table is one of the latest updates of the Polypad as well. And then, of course, these numbers are familiar to us, but we didn't jump to conclusion really fast. I gave them another Polypad. It's easy to make it because I just copy and paste another row. And in that one, maybe it's better for me to show this in the big screen. Yeah, in that one, they did it by 1. Okay, now we are almost sure that these are the Pascal triangle. And you know, in Matigon library, they can cheat a little bit because here we have got the Pascal triangle already. They can use everything they want. And after that, let me just close this. I asked them if they can find the numbers, find a new distribution without actually listing all possible paths. So they come up with the answers. That was really fun. And we talked about the binomial distribution, normal distribution, the bell curve, and these are the best that I can draw a bell, as you see, unfortunately. And finally, even when we have this, after like 3 or 4 flips, you want to change it, right? You tilt it a little bit. You want to change the distribution. Am I right? Because nobody likes normal. Everybody wants to change. Normal is boring. So we moved to another one. In that one, in fact, I just gave them to this version that we have just finished in the previous lesson, the sample space and the distribution. We name it as disturbance in the distribution. Do you feel the disturbance in the force? And now they put some bars anywhere they want. They've created those, and then they calculated the new distribution, new outcomes, new results. And then we talked about what did you resolve, what did you realize, and how this is related to our sample space without listing the paths or routes, how we can find the numbers. Is it related to like these numbers over here or the location of the bars, and etc. That was really fun. We enjoyed a lot, and anything in real life, anything you can hold, I think that you can kind of simulate by using Polypad. So I really thank you for creating such a powerful platform for teachers. Thank you.
Thank you, Ada, for creating such powerful activities. I love that idea of the block there, right? Like when students
yeah.
the normal distribution, even just how you phrased it is so like joyful, and just go go play, kids, go put a block somewhere and see what happens. And can they begin to make some conclusions about what happens when blocks are in certain places? What a great extension of that activity is so cool. I put a number of links in the chat as Ada was talking. One that I just want to share is some Polypad templates that we've made. And I was doing an activity with my students this past week on flipping coins and dice. And so there are all these canvases that have, here's a canvas with 100 coins and 100 pairs of coins and then 50 sets of 3 coins. They don't take long to make, right? Those are like, you can copy the coins really quickly. You can take a set of 3 and copy them, but they're pre-made. And the beauty of it is you can flip all the coins or roll all the dice at once. We were doing a probability experiment where when you roll 4 dice, what are the chances of getting at least 1 6? It's a famous probability game from Chevalier de Mere. In one homework assignment, we generated 12,000 trials of that. Just because kids had a canvas with 30 of them. I had them do it, I think 20 times or something. They kept track of their data. It was like a 10-minute homework assignment for them that they had fun with. But when we came in the next day and they put it into the Google Sheet, our experimental probability was really close to the theoretical. And they believed it because they saw, they didn't see all 12,000, but they saw the 500 they did, and they knew that their classmates did the same thing. I think there's all sorts of code you could write, take 4 dice and flip it 12,000 times and tell how many have at least 1 6, and you can get that number. But I think for kids to actually do it and see it themselves, like we've seen so many examples of tonight, is really, really powerful. The seeing is believing there as well. Thanks for coming to listen to these awesome teachers. We will end the webinar. Thank you for coming and have a great night.